Hey everyone. Hey everyone. Thanks a lot for joining this webinar on trust and data quality. Yeah, let's do it a little bit more, less like a webinar and more like a dialogue. So if you have any questions, then just go ahead. Yeah, so let's take a look at the agenda. First of all, we're going to take a look at the consequences of unreliable data, what are the symptoms. Then we'll take a look at which solutions are in the market, what can you do, and then how we see, at Y42 see the future. Or maybe there are people joining by the minute, by the second. So yeah, but still on the agenda side. So yeah, as I said, how we at Y42 see the future developments and what our point of view is and what we want to build in our product. And in the end, we have some Q&A and a discussion. But to be honest, you can, if you have any questions in the middle, you can also just ask them. Yeah, thanks a lot for joining. First of all, I mean, I'm working for Y42, which is a data analytics platform, an end-to-end data analytics platform, which is very easy to use. It's headquartered in Berlin. We have, at the moment, we are over 150 people who are very excited about data and about the modern data stack. The company was founded 2020, so 2 years ago, by Hung Dang, our CEO. And until now, we've raised a seed round and 30+ million Series A round. And at the moment, we're building the second version of our app. Y42 is, you could call it modern data stack in one product, the modern data stack in one product with very high usability, very low entry point for business analysts. And especially in our version 2, it provides data engineers, still provides data engineers with all the functionalities that they love, like version control, it's fully programmable and so on. But it still has a nice user interface. So you can use it as a business analyst, but also as a data engineer. Yeah, so just a few things that you can do on the platform is you can integrate your data from multiple sources into one data warehouse. You can run data transformations on your data, on your tables. You can visualize them afterwards, or you can export them to other tools and take action based on your insights. Yeah, so that's about it for Y42. If you have any questions, let me know. Then, yeah, I'm a product lead at Y42, a product lead for our data pipeline. So I'm very happy to have joined this team because everyone is very eager to support each other. So it's a very nice work environment. And yeah, outside of work, I mean, at the moment, I'm very interested in raising plants. So if you have any tips on that, please let me know. Because like, I'd say 50% of my plants are dying. So if you have any tips, please let me know. And also at the moment, I'm trying to refresh my Mandarin skills because they got really rusty. So yeah. Let's get started. So what are the consequences of unreliable data? So what's the problem? I mean, imagine you have an e-commerce store or whatever, and you load your data from your Shopify account, or you've done some Snapchat ads, Instagram ads, and you want to load your data into your data warehouse. Or the data can even come from MySQL or your Postgres database, or even from a Google Sheets that someone has manually entered the data into, and you want to have everything into one place to do some analytics on it, to do some data transformation on it. So how can you be sure that nothing is missing when you integrated the data, imported the data? How can you be sure that the data did not get corrupted, that the person entering records did not make any mistakes? So yeah, where there's the big problem is when your stack grows bigger, is that there's no source of truth for, there could be no source of truth for important data. So data engineers have to do some ad hoc solutions, develop some ad hoc solutions, which is very hacky. There could be no clear definitions. So no documentation on how specific metrics are calculated. For example, lead conversion rate. What do you, when does someone qualify as a lead? That's just one example of it. Then analytical glitches could weaken users' confidence in your data insights. And yeah, as your stack grows bigger, you have 100 models, 100 tables, 1,000 tables, and you might not have documentation, clear documentation for all of them, and you don't know where the data came from and if you can use it or not. And like data debt is equivalent in the software engineering world with technical debt. So yeah, and technical debt is very bad and you have to solve it later, and it takes a lot of time to solve it. Yeah, who is affected by this? I mean, in the end, everyone is affected. But if you start your data journey, or if you are at the start of your data journey and you're doing everything manually and you don't have that much data, you can still manually go through your Google Sheets and so on. And if you have 200 orders in your e-commerce store, then one person can check them. But as your data stack grows, as you get more orders, or when you do more ads and so on, and you put everything in a pipeline, then you kind of want to automate things more. One person can't check everything. And that's when you really want to go into data testing. I mean, yeah, as you can see, as an engineer, you want to know, you know that your pipeline works, so at least it doesn't throw any errors. But the data inside the pipeline, how do you know that this data is not faulty? As a data executive, how can you be sure that you're not acting on some faulty analytical insights? And as a data analyst, yeah, when everything is small, when your data stack is small, then your hacky solutions might work, but you cannot monitor hundreds of tables manually. So at some point in your data journey, data testing will become a big enough issue that you want to deal with it. Yeah, the same goes, I mean, the problems can arise in the upstream or downstream. And I mean, yeah, it's basically the same problem, but in a different, shown in a different way. So the question becomes, when should you start testing your data? When should you start monitoring your data? I mean, the textbook answer would be that you should do it right away, right in the beginning. But then again, I mean, you have to prioritize. You have limited resources, limited amount of time. So even in software development, you wouldn't, like when you are a small company or when you just are trying to build your first version of your app, then you wouldn't write extensive tests for them. But you would start at some point when the problem becomes big enough so that it makes sense to allocate resources to tackle this problem. Yeah, so what solutions are there for data testing? So when you become big enough, when you have a lot of data, then data quality actually becomes an issue. So how do you deal with it? I mean, in software development, you have unit tests, right? You can test your functions, and this is spilling over to the data space, where you would test your data. It's equivalent to unit tests. And there are a few solutions in the market that we will take a look at in a bit. So the question becomes, when do you test your data? When does it make sense to test your data? Testing makes sense when the data is not only with you, but it changes hands. So if the data, someone else uses the same table, and yeah, you need to, when you give it to someone else, you need to verify that the data is in a good state, or when the data changes the system. So when it moves from the source to the data warehouse, or from the data warehouse to a third-party solution. And how do you test this data? There are multiple solutions. One of them would be Great Expectations, where you can set expectations for your data, and then you can test it against existing data in a data pipeline. So you could build an Airflow pipeline, and at every stop, you could test the data using something like Great Expectations or some other tool in the market. Yeah, so as I said, software best practices are spilling over to the data space with a delay, and data testing is equivalent to unit testing in this context. And what tests are there? You could check if a column has null values, if it has a unique values, or if the values in a column are unique, if the values are in a specific set. So for example, if you have data about taxi rides, then you want the number of customers per ride to be between 1 and 4 or 1 and 5, right? Because there are only that much space in a car. You could test if a specific columns exists, or you could test referential integrity, which is you check columns in two tables. For example, let's give an example. You have an orders table, and you have a customers table, and you want to check the customer ID column in the orders table if they are present in the IDs column in the customer table. So do the customers exist that ordered something from your shop or something like that? And let's take a look at one example of when you would test your data. So let's imagine one use case. You have Shopify data, you load it into a data warehouse like Google BigQuery, then you do some data transformation on it, and then you export the data to an Azure blob storage. And all that is orchestrated via Airflow. So all the yellow buttons are where you could set up some data testing. So you could test your data before you load it into the warehouse. You could test it after you load it into the data warehouse, or you could do both to check if your data is still not corrupted, or it's still in the same state as you expect it to be. And then you run some data transformation. And afterwards, you check if the data is still in a good quality, good enough standard. And then you send it out to another service, and afterwards you could still test it. So you should test it whenever it changes hand or it changes systems, right? So yeah, do you have any questions so far, or was everything quite clear? Otherwise, we would take a look at how you could write data tests. Okay. Okay, so let's show you how to write data tests in a little demo. I wanted to create a demo that's a little bit more more on the production side. So it's not only on my local laptop, but it's on the cloud, and it resembles more the way you would do it when you would work in production. So first of all, I created a virtual machine instance in Google Clouds. I started it here, and then I opened it in a new browser window, which you can see on the left. Then I loaded some data into BigQuery, like this. And then I installed Python on this virtual machine, which runs on Ubuntu. I installed Great Expectations. And now let's take a look at how you can set up some tests in Great Expectations here. So first of all, you would run this command, Great Expectations init. You would initialize Great Expectations. Then you would create a new data source. Let me just show you how it looks like. Data source new. Oh, sorry. You would also have to install SQL BigQuery, SQL Alchemy BigQuery. It asks you if you want to check out a local file or a relational database, then you choose a relational database in this case, because you want to connect to BigQuery, right? Here you choose BigQuery. It runs the notebook, and then you can open this notebook and set up BigQuery. If you want, I can tell you how to do it offline, but now it would take a little bit too long. So I've already set it up. And here, next I would create a new suite. And then it asked you, how would you like to set up your expectation suite? In this case, I would use a profiler. Which data source do you want? I want my BigQuery data source. I want my customer table. Name of the expectations, let's call it test. And let's do this. So it starts this one. It created this test2. And then in this case, I would just run these whole commands. I would do unignore this one. So these are your columns, right? And if you just how do you call it again? Comment these out, then they won't be ignored. But I will only comment out one because it takes too long to run. Then I would run this one. The rest I would just run as is. I won't run it now because it does take too long. And afterwards, you have your suite, or your, like, it auto creates as tests for you, and then you can take a look at them when you type in edit expectation underscore webinar. You can edit the test that you created. So basically, the workflow would be that, first of all, you would use their auto profile to create tests for you, automatically create tests for you, so you don't have to do it. You don't have to start on a blank slate. Then you would edit those tests, and the tests look like this. The tests look like this. You have table level tests. So the first test, this is one test basically. This is your data set. And then this function is basically a test. So this one tests if the table has the columns in this list. This one tests if table row counts is between 100 and 100. The test that it auto generates for you, it's really simple and naive. So you have to actually go in there, and it's actually overfit on your data. So you have to go in there and edit it. And here you have column level tests. You have a test for the customer ID column, like expect the minimum of this column to be between this and this, maximum, test if there are null values and so on. And if you want to write a new test, then you just type in validator.expect column values not to be null, and then you type in the column, or you take a look at grid expectations documentation to see all the tests that are possible. And here it shows you the tests of all the columns and on the table level. And if you want to check, one second. Oh no. Here, you would just run grid expectations, checkpoint, checkpoint new, and then suite is a collection of tests. And I've done this one already. So when you do this, then it shows you, it runs the test against your data and shows you which tests succeeded, how many tests were run, which tests succeeded, and if it didn't succeed, what were the values that you observed, or which were the values that didn't expect the test. That's it for the demo. If you have any questions on how to run it, I mean, just text me and then I'll help you to get it running. So let's go back to the slides. Yeah, so this was a demo of how to run grid expectations on the cloud, like in a virtual machine within Google Cloud Services, and running it against your BigQuery database. If you have any questions or anything, let me know, and I'll try to help you to set it up. So now let's talk about how we at Y42 see it, and how we, what is our view on data testing in the future. So we were thinking, okay, we want our users to be confident about their data that they have in production, that they have on our platform. We want to notify them when a test failed or tests fail, and we automatically roll back to the last version that worked. And we want to send out alerts that users can set up based on some business logic. Like, for example, send me an alert when the revenue falls below 50% of last month, or something like that. Or if the revenue of the US region is lower than the revenue of the Europe region or something like that. We want to send out regular engineering and business reports or dashboards, and we want our users to be able to trigger webhooks based on some predefined scenarios. So that's why we were looking into multiple open source solutions, and we're looking into like how we can how we can run them under the hood or run them on our platform. The one issue was that, data quality tools at the moment, that there's no standard terminology for data quality in the data quality space, because it's everything is very new and all the solutions are quite new, and there are obviously different ways to solve the same problem. So as a business, you really need to do research on which problems you actually want to solve, because everything looks shiny, but you really want to dig in, like what are actually the things that you have to solve. So we were looking at a few open source tools and try to take a look at what are their shortcomings, and if we can use it in Y42. The biggest problem was with most solutions, and we show 3 here, is they cannot run on large data sets. The issue was that they use pandas under the hood. So pandas loads everything into memory, and therefore there's no native support for large data sets. If you want to run it in a data warehouse, you would have to download the data, turn it into a pandas data frame, and then run the test against them. And if the data is large enough, then you can't do it. I mean, they do have support for, if you want to run it against large data sets, you would have to use a third-party tool with them. At the end, we found 2 solutions for running against large data sets, which is Tensorflow data validation and Great Expectations, because Great Expectations uses SQL Alchemy to run SQL queries against the data warehouse, or you can do that. And TensorFlow uses Apache Beam and turns the table into a protobuf, which is a mechanism for serializing structured data. Like it's something like XML or JSON, but much smaller, faster. And Apache Beam, I mean, it's a model for defining and executing data pipelines. The issue with TensorFlow data validation is that it's a little bit slow, because you have to spin up an instance and you have to load the data and turn it into a protobuf. So in the end, for us, at least, it took longer to run the data test than it took to execute a data transformation, which is not acceptable. And Great Expectation just runs a SQL query against the data warehouse like BigQuery, so it's rather fast. So that was good. The issue was with Great Expectations is that it has high costs per test. So for example, like imagine you have a table with 10 columns, and you want to check for every column if there are null values. For some columns, you want to check if the values in them are unique. And then in the end, you would probably run 4, 5, 6 tests on table level to check if columns exist and so on. And you would run probably 4, 5, 6 tests per column. And each of those tests is one query against a data warehouse, for example, BigQuery. So basically, you're running 5 queries for each column. So your cost for running your test would be 4, 5, 6 times the cost that you would have when you run the actual data transformation or like your SQL query. I hope that was clear. So yeah, that was a big problem with Great Expectations. So that's why we decided that we will implement our own solution for our customers, a custom solution. So the other thing is that what are let's say the pros of having an end-to-end data stack platform. What are the advantages for the users? One advantage is obviously that, or let's start with a downside. The downside would be that it's very opinionated. So you can't use the exact solution that you want. But then the big upside is that you don't have to set up anything. All the best practices are already implemented from the beginning with very little effort. So even in the beginning of your data journey, you would have all the best practices already in that platform. Everything is centralized, and you don't have to maintain your data stack, or you have no maintenance costs for software, which is one of the biggest costs on time and effort, and actually on your nerves when you create a custom solution. Yeah, and you have everything out of the box basically. But there are obviously downsides, because if you have your custom solution, then you can build it, customize it as the way you need it, and really customize it to your needs. Yeah, I hope everything was clear so far. If you have any questions, let me know, or just speak or write it in the chat and I will read it. Yeah. So basically that was it from my side. So if you have any questions, please let me know.
So if I may speak, first of all, hi, great presentation. Thank you so much, for sharing all the insights. I just wondered, because in the middle of your speech, I understood that you were actually considering different open source projects that are able to test the data reliability, and then you ended with a statement that you are kind of thinking or already developing your own solution. And just wanted to understand, what's the vision here? Do you basically plan on developing over some sort of open source, or are you basically thinking of completely building from scratch a new feature of the product?
Yeah, so a great question. So actually, the first thought that we had is, how easy is it to just implement an open source solution under the hood for our data platform, because we have an end-to-end data platform for our customers, right? And it would be much easier to run an open source solution under the hood. But the big problem with Great Expectations that I mentioned was that for every test that you create, and you would probably create 4, 5, 6 tests per column of your table, Great Expectation runs them as one single query or one extra query. So every test would be one query against the database. So if you have four tests or 5 tests per column, your costs for running the test would be 5 times as high, or more than 5 times as high, as running your data transformation. So you would run your table transformation, and then you would run the test afterwards, and the test would cost you 5 times more than actually running the table. So we thought we could do it much more efficiently, and that's why we did it. We did an own solution. And the second thing is that within one test suite, Great Expectations runs the tests sequentially. So that would actually take, like, performance-wise, we could do it more efficiently by just running all the queries in parallel.
Okay, perfect, makes sense, and thank you so much for the answer.
Yeah. And I mean, just to add to that answer, like, we analyzed how much time it would take to build custom solutions, and it actually doesn't take much more time to build our custom solutions than to integrate an open source solution. And also we wanted to use it for business alerts, and grid expectation doesn't really help you with business alerts. And smaller things are like, there's no good tests for testing columns against two tables. So if you want referential integrity tests, like test if the values of one column within one table are present in another column in another table, then there's no grid expectation test for it, at least not in the core expectations. Yeah, can we implement on DigitalOcean or Docker? Thanks for that question, Shaunak. What do you want to implement on DigitalOcean or Docker? Y42 or yeah, yes, you can. Yes, you can. I mean, yeah, you can run grid expectations within a Docker container, and you can implement it on DigitalOcean. Yeah.
Hi, Paulina here. I just wanted to ask some questions from the people who registered. Yeah, thank you so much for the presentation, by the way. So we have a few questions, and first is, so what are the signs for the company that you can maybe mention that they are ready for the for data testing? Maybe just like a few things.
Yeah, that's a great question. So yeah, as a company, when you grow as a company, you have limited resources, right? So you want to tackle problems as they arise, and basically with data testing, I mean, if you have a small amount of data, then you can, or if one table is not that big, then you can just check the tables manually, and maybe then it doesn't make sense to like set up a data testing framework to do it automatically for you. But as soon as one person or multiple people in your company spend a significant amount of time fixing data issues or checking if a table adheres to specific standards, then it makes sense to start implementing a solution. Yeah, either end-to-end solution or an open source solution.
Awesome, thank you very much. Also, we have a question about the processes. So for example, if a company doesn't have any process in place, what will be the best way to start, or just like the first steps for a company to start if they have not any process in place yet?
Okay, so I suppose it's about like when you would test your data, or what would be a good turning point for testing the data, right?
Right.
Or yeah, okay. Yeah, I mean, as I said before, it makes sense when data changes hands within your team or within your company or across teams. Then it makes sense to run a test, automatic tests against the data to see if it adheres to specific standards or if it has been corrupted in any way. And then another thing is when it changes systems. So if you load data into your data warehouse, it makes sense to test it when it's loaded into the data warehouse. Or if you send it from a data warehouse to a third-party solution to do some actions with your data, then it makes sense to test if the data still has adheres to your standards.
Awesome. I think these are all the questions that we have, but it will be also nice to maybe chat with some of you if you have, if maybe someone has anything to share. For example, if you would like to share your experience in implementing those processes, or or if you have like ideas or opinions, we would love to hear from you. Is there anyone who would like to share anything? I guess people are a bit shy, but let's give everyone a couple of minutes.
Yeah. And also, I mean, if you have any questions on the demo, like how to set it up on Docker, or how to set up grid expectations on GCP or on another cloud platform, and run it against a data warehouse or something like that, then you can definitely just write me a message and I can point you to the right directions.
Right, so we're gonna share the recording and also like your LinkedIn and the contacts where you can ask more questions. We had one more question, which was about the data stack best practices. So maybe you could also tell a little bit about that. So how technical should the team be, and what are the data stack best practices for implementing it?
Yeah, so I mean, the typical open source data stack would be that you have a data warehouse like BigQuery, or a Snowflake. You run dbt on Snowflake for data transformation. You run grid expectations for data testing, and then you use Airflow, something like Airflow or Dexter or something for your data pipeline. That is one way to do it. You would need at least one engineer, one data engineer, or whatever they are called these days. There are many names for them, analytics engineer, I suppose, to set them up, which is not that easy. I mean, it's getting easier, but it's not that easy to do it. And the other way would be to use an end-to-end solution where everything is managed for you, and you only have, you basically only have to connect to a data warehouse, and even that is being done for you. And in this case, you don't have to, you don't need an engineer or a technical data team, but one or two data analysts or business analysts could also be enough.
There's a question in the chat. Can this handle doc stores?
Do you mean like PDFs? And I do not think that they can do that. You mean grid expectations, right? I'm not sure, but I think they cannot. Yeah.
All right, awesome. I think these are all the questions. Yeah, as I said, we're gonna send you a recording, and if you have more questions, you can always reach out to any of us. We're gonna send you the email with all the contacts, and it was great having you today. Thank you everyone for joining. I hope that you will join next time as well.
Thanks a lot for joining, and see you.
Thank you, Hai, for the great presentation. See you next time.